Okay, we're going to do our last word for heat transfer, okay? Now, this one is going to give you some trouble, all right? This one gives everybody trouble because this one's a bit odd, okay? This one is called convection. Now, some of you guys might have heard that word before. Some of you guys might have a convection oven at home, which basically works. It blows the heat into your food, all right? Rather than just the oven coming on and heating up your food, a convection oven circulates the heat around your oven, which leads to better cooking, so they say. So the conduction for that heat transfer, the definition for that one is going to be the movement of heat through liquids and gases, okay? The movement of heat through liquids and gases. All right, now let's talk about some gases. We're not talking about gasoline you put in your car. All right, one of the gases we're talking about is obviously and mainly air. All right, air is a huge gas on our earth. Oxygen, we call it oxygen. Mainly it's that's exactly how convection is going to work. Is it going to go through these gases and these liquids? Liquids we're going to do first, okay, and then we'll do gases next. So the first thing I want to talk about is how convection works in liquids. All right, so I'm going to give you an example, okay? Let's say that we have a pot of boiling water, all right, and here's your handle. Now I'm going to draw another heat transfer on here, and I hope that you understand what it is. If you put the pot on a gas stove and this fire right here is below it, what type of heat transfer is that if the fire is touching the pot of water? Do you guys remember? We just did it. That would be conduction. Remember? We talked about how the lady conductor had the wand in her hand. She was touching the wand. So these flames are touching the pot. So that's going to be one heat transfer. But we're not going to worry about conduction. We already went over that. There's a bunch of things we're going to talk about at the end of the next video, that all three heat transfers can be involved in the transfer of heat. And we'll talk about that in a minute. So if any of you guys have ever fixed yourself your own food before on the stove, which I hope that your parents were home when you did this, because some of you guys using a stove actually terrifies me to death. But nevertheless, we're going to talk about this heat transfer. So if we have a pot of water, okay, and let's say that this pot of water is going to be cold, all right, so the water is going to be cool, all right. So with the water being cold, you just got it out of your sink, you're going to place it on the fire. Well, obviously, the pot is going to get hot first because it is conducting onto the fire. This is the interesting part about convection. So as you noticed, if you have cooked, when you put the pot on the stove, it's not instant. The pot of water does not begin to boil instantaneously. That would be quite a miracle. So this is how convection works. So if you look at this right here and you look at this fire, and you got this fire ramping up and it's touching your pot, well, which part of the pot of water do you think is going to get hot first? Okay, and I hope that all of you said the bottom, because it's closest to the heat. So what happens is you get an area of hot water, okay, down in the bottom. And we've gone over some of the things that we've talked about as far as hot and cold air. Well, the same thing stands for liquid. We talk about how hot air rises. Hot liquids want to rise because they're lighter. Cold things want to fall because they're heavier. It's the same thing with convection. So when things like this start to happen, hot rises, and cool falls. So this is how a pot of water starts to boil. And if you don't believe me, you can go try it on your stove if your parents are home. So when the fire is touching the bottom pot of the water, this water gets hot at the bottom. And if we follow our rule of the hot and the cool, what do you think happens to the hot water? Well, I hope that you said, Mr. Allen, it's going to rise to the top. And you're exactly right. So now you got the hot water, up here. All right. The cold water, should have used the blue for that. The cold water is going to dump down to the bottom of the pan. Okay. It kind of gets this little action right here. Hot goes up, cold comes falling down. So once that cold air falls down again, that cold water, falls to the bottom of the pot, then you have new water down at the bottom that's cold. The heat is going to heat up that cool water so that it gets hot, and it's going to rise, and then more cold water is going to fall again. And then before long, you're going to have a recipe to have all the water the same temperature, and when that happens, the pot of water begins to boil. All right, so that's going to be the first example. I hope that you understand that. I have a better picture of it on my PowerPoint, but it doesn't really show up that great on the iPad, so I'm not going to give you that example. Let's talk about another one, and this one's going to be a little funky to talk about, and the only reason is because we haven't spoken about the weather, but I'll give you a little bit of a little bug in your ear, so we said in class, about how these clouds are made. So I'm going to erase this, and I'm going to do one of my favorite little preemptive drawings. I am going to do the land, and we can do some water as well. We don't have to necessarily do both, but we will. Now, we have land and water, all right? Actually, you know what? We'll just do land. We don't need to do this. We're not talking about wind today. We'll just do land. Now, when you have land stands still. You know, I mean, in the event of an earthquake, I guess the land would shake a little bit, but for the most part, the land doesn't move, and the sun can hit it directly. And when the sun can hit something directly, just like it hits you directly when you're outside and you don't have a tree to stand under, you get hot. So what happens is when the sun radiates its heat, there's another heat transfer word, radiates its heat down to earth, it heats up the land. It makes the land hot. And when you make the land hot, well, what do hot things want to do? Hot things want to go up. So they start going up, okay? All this heat starts going up. And what does the cold air up above it do? Well, it starts to fall. Awesome job, man. I hope you guys understood that. It starts to fall. And then before long, we have this very hot heat going on in the summertime. That's how all this heat builds up around here. So let me show you how clouds are made. And if you've gone outside and you've seen birds flying that don't look like they're really flying, they look like they're gliding, well, they're using the heat transfer of convection as well. So let's talk about that. So I'll go ahead and I'll draw some land, all right? So here's your land, all right? And let's say that here's the sun up here. The sun is going to radiate its heat down onto the land, and then it's going to start to bounce off the land, and that hot air is going to rise. Now, if you've looked up in the air before, you've obviously seen clouds, right? And some clouds, they all look a little different. But usually the puffy ones, the cumulus clouds, the cumulonimbus clouds, things of that nature are going to grow because of convection, all right? So when the heat from the sun radiates down onto the land, it's going to bounce off the land, the heat's going to go up, and then it's going to start making clouds grow, all right? So this can make cumulonimbus clouds grow to extremely high levels, okay? Cumulonimbus, and even some cumulus clouds can grow this way as well. they're not going to be nearly as intense as the cumulonimbus clouds. But when we get into clouds, you'll start understanding this is how these clouds grow. It's because of convection. And a lot of weathermen call that convection. When they see a huge thunderstorm coming that looks like a bunch of cotton, that's a cumulonimbus cloud, and they'll say, hey, wow, look at the convection on the horizon. And that is basically because of the heat rising off of the land. All right, now listen, this is a really, really tough concept, and I don't expect you to be a pro at it after the first time you listen to me, but if you listen to this a few times, I think that you'll understand it. I think the best example for the moment is the pot of boiling water. And just remember that the water at the bottom of the pot is going to heat up a lot quicker than the water at the top of the pot because it's a lot closer to the heat. And then that liquid's going to rise up to the top. The hot water is going to stay up there and the cold's going to go down, and then it gets hot and it goes up, and then before long, like we talked about, it's going to start boiling. And that's why your mom always says, a watch pot never boils, because you sit there and you watch it forever and it seems like it takes forever, and then you go back and look and the water is boiling. So it does take some time for water to boil, because convection is something that does take a few minutes, okay? Now, I hope you guys have gotten something out of this. I'm going to give you guys some questions to go off of, and hopefully they'll help you. I'm not really sure how all this works. I guess we're just going to have to do trial and error for a while and see what goes well and see what doesn't go well and see what works and see what doesn't work. So if you are tuning into these videos, I really appreciate it. I hope you get something out of it. You're not going to be able to comment on the videos because I made it for kids, but you guys can always shoot me an email, all right? And you know it's jim.allen@nhcs.net, and I look forward to hearing from you. You know, I'm going to post these today. It's Thursday. I know we're not going live till Monday, but I'm going to see if I can get these posted today, give you a little bit of work to do, see if I can get my code out to y'all, see if Miss Moore will get my code out to you guys, okay? But look, I hope you tuned in. I hope you learned something. And if you didn't, just go back and listen to the videos again, all right? And I hope you have a good day, and I'll see you soon, all right? Bye.